Hi, my name is Dai Matsuzaka, and today we're going to be working with Chapter 4.4, Radical and Rational Equations. Okay, so radical equations generally take the following format. Ax plus b to the square root equals cx. Now, we want to know, how can we solve for x, right? It's under a square root. We've never seen this before. Well, in fact, you actually kind of have, right? The discriminant of the quadratic formula is actually just kind of a radical equation. But in this case, we have x, which is inside of the radical equation, and also x to be outside in the equality. So we need to be able to find a way to figure this out. How do you isolate for x? Well, we can do something like this. Ax plus b square root to the power of 2 equals cx to the power of 2. Then what do you get? You get ax plus b equal to c squared x squared. Now this is a quadratic equation. You know exactly how to tackle this. You have a formula, you have factoring, right? You have many skills you can use to solve this equation now. So the key is to actually just square it. If you square it, that's a radical, the square root goes away. Once it's out of there, now you win. You're done. So let's just do this case, right? Square root of 2x plus 3 is equal to x. Well, again, just square it, and you get 2x plus 3 equal x squared. Now we just follow our factoring skills. So 0 is then equal to x squared minus 2x minus 3. If we factor this, we get x minus 3x plus 1, right? Minus 3 plus 1 is minus 2. Minus 3 times 1 is minus 3. So you're done. Your solution should be 2 of them. X is equal to 3, and x is equal to negative 1. So yeah, this is actually just kind of wrapping up what we've done. So we have to transform the equation into a quadratic equation first. What does that mean? That's actually just the squaring that we just did. Then you have to factor that quadratic equation or use the quadratic formula to arrive at some solution. Then finally, we just want to verify the potential solutions derived by the quadratic equation by inputting them into your rational radical equation. So in this case, we have x is equal to 3 and x is equal to negative 1. Well, does this actually make sense? Well, we kind of ended at, okay, we have our solutions, we're done. But I want you to really think about what we have here. X is equal to negative 1. Can a solution be negative? Well, let's just try to input it here, right? 2x plus 3, whatever this value is, can this actually equal negative 1? No, it can't. Square roots can't be negative, right? So what does that actually tell us? Well, it tells us that the quadratic equation and its factoring or its formula will give us potential solutions. But we actually have to hand check each of the solutions to make sure that it actually works. So in this case, x equals 3 works because then you have square root of 9, which is equal to 3. But negative 1, this actually doesn't work out, right? A square root can never equal a negative number. So there you go. You have that the actual solution to this is only x is equal to 3. You have to be careful with this one. Right. Now we're going to look at some things called rational equations, where we have, if you remember the definition of the divisions with polynomials, that's a rational. So something like p of x over p2 of x is equal to p3 of x, right? So this is a rational equation. But what you do is you actually multiply both sides of the denominator so that you get a simple or simpler p2 of x, right? And then you can actually solve this quadratic equation and verify that potential solutions is valid in the original equation. So let's look at some examples. So we have 2x plus 10 over x minus 1 is equal to x plus 2. Well, we want to solve for this, but how do we do that? Well, we just first multiply x minus 1 on both sides, so we can isolate for x in a sense. Then we have x plus 2 times x minus 1 is equal to 2x plus 10, as you can see right here, right? Then what do? Well, you actually solve x plus 2 times x minus 1. You expand it out, you get x squared plus x minus 2. At this point, then, you actually isolate for x in the sense that you make it equal to 0. Then you get x squared minus x minus 12 equals 0. At this point, Finally, you have a form in which you can actually solve. This is going to be equal to x minus 4 times x plus 3 equals 0, right? Minus 4 times 3 is minus 12. Minus 4 plus 3 is minus 1. So this is a factorization of this quadratic equation. So your potential solutions is x is equal to 4 and x is equal to negative 3. As we discussed in both the theorems, we need to check if this is actually a good solution. So let's check. Let's put them in the original equation here. So x is equal to minus 3. Does it work? Well, quick computation. It does work, right? We have minus 6 here. Minus 6 plus 10 is 4. 4 divided by minus 3 minus 1 is minus 4. Minus 4 is equal to minus 3 plus 2 minus 1. There you go. It works out. How about 4? You can verify that it works as well. Now, finally, we're going to be looking at absolute value equations. It's going to be looking something like ax plus c is equal to x. Now, these absolute values are a little bit hard to deal with, and you're going to encounter them quite often. For the SAT, we're going to be working with basically just getting rid of the absolute value first, because the computation with absolute values is actually quite nuanced. Getting rid of them is much easier to work with. But how can we get rid of an absolute value? Well, we just square it. This is actually equivalent. You can take that into x squared equals 2x plus 1 squared, right? Because for any absolute value of this, right, if you take that square of it, it's still equivalent. Now we know how to deal with this because this is just a quadratic equation. Now we just have x squared equals, this is what, 4x squared plus 4x plus 1. Then we just subtract x squared from both sides. You get 0 is equal to 3x squared plus 4x plus 1. You might need to use the quadratic formula for solving this one. But once you do, you have to verify that this actually satisfies the equation. Now, let's work with a simpler version so we can easily factorize. Say we have absolute value of x plus 1 is equal to x, right? If we square this both sides, we get x squared plus 2x plus 1 is equal to x squared, right? Now we can actually get rid of the x squareds, right? They cancel out. This is really nice. So then 2x must equal negative 1, x must equal negative 1 over 2. Now, is this a valid solution? No, it's not, right? Because if x is negative, well, it has to equal the absolute value, but absolute values are always greater than 0. So this actually doesn't emit a solution. What if, in the other case, we have x minus 1 is equal to x? We're the same thing, right? X squared minus, this is going to be minus 2x plus 1 is equal to x squared. Well, we cancel out the x squared as we did previously, and you get x is equal to 1/2. Does this work? This does indeed work, because when we put 1/2 into this equation, we get 1/2 minus 1, absolute value, equal to 1/2. Does this make sense? Well, it does, because 1/2 minus 1 is negative 1/2, but under the absolute value, that is just 1/2, and 1/2 is equal to 1/2. And that's how you know your answer is correct. So be careful with absolute value equations. They don't appear much in the SAT, but if they do, just take the square and see if the solutions that arrive from solving that quadratic formula actually work. Namely, we want x to be positive. If it's positive, then it will work, and that will be your solution. If it's not positive, it's negative, then you know automatically that that solution fails. And I'll see you in the next chapter.